unlike reversible process. Ano pa yung mga factors na nakaka-affect doon sa ating process like friction, expansion or throttling, heat transfer through a finite temperature difference, or mixing of two different substances. Okay, so pagka meron na tayong ganun, hindi natin sila pwedeng basta i-neglect. So meron silang effect doon sa path, doon sa process, doon sa system. In such a way, hindi na natin siya pwedeng sabihin na reversible. So it will be considered as irreversible process. Okay, the main effect of irreversibility is always to decrease the useful energy output or to increase the energy required of the process or system. Okay, punta na tayo sa isometric, yung ating first process to identify. Okay lang, mag-off na ako ng video ha, kasi nakatungo lang din ako eh. Dito na ako mag-solve sa iPad. Okay, so the first process is the isometric, or the other term is isochoric process. Okay, so do not get confused with the two terms. They are identical. Okay, when we say isometric process, it is the manner of changing the state of thermal condition of fluid at constant volume. So the keyword is constant volume. So it could be internally reversible or internally reversible. Okay. So as an application of isometric process for a non-flow closed system, let us consider drawing the figure or the diagram to illustrate an isometric process or an isochoric process. Okay, so let's say we have this system. Okay, let's say we have this system. Ayan, so ito yung ating system. Okay, the change in work, okay, kapag ka daw tayo ay sa isochoric or isometric, this is equal to 0. So meron tayong added heat or the change in heat being applied to the system. Okay, so if we are going to draw the PV diagram of an isometric process for a non-flow closed volume, ito ang itsura niya. Okay, we have our PV diagram, pressure versus volume, or it can be a specific volume. Okay, so sabi natin, ang isometric process is constant volume. Okay, let's say we have our P1 or the pressure at state 1. Okay, so and this is the volume. So let's say at this point, ito yung ating state 1. Okay, where meron tayong P1 and we have this initial volume. Okay, but then sabi natin at a certain period, nagbago, so na-achieve niya at this point pagdating sa second state or from process 1 to 2, okay? So, yung ating volume is constant, which means that the volume at state 1 is just equal to the volume at state 2. So, ito ang itsura niya sa kanyang PV diagram. O, lagyan lang natin ng arrow, which means that yung ating process is from state 1 to state 2. Okay, ganito ang itsura ng figure natin or ng ating isometric process in a PV diagram. How about in a TS diagram or temperature entropy diagram? Okay, let's have our S here and our temperature there. Okay, so from a specific temperature, okay, constant volume. So, yung relationship niya later on, papakita ko yung state relations o yung relationship between the different parameters or properties of isometric process. Okay, from state 1, okay, let's say from a certain period, so ito yung ating entropy. So, ano ang nagiging relationship? Okay, ayan. So, ito yung ating state 1. And then from a specified period. So ito naman yung ating state 2. Ayan. So, and lagyan natin ng arrow, which means from state 1 to state 2. So, eto naman ang itsura ng ating TS diagram or temperature entropy diagram of an isometric process. Okay, so these are the state relations ng ating isometric process. So we have the pressure and temperature relation. So sabi kanina, the manner of changing the state of thermal condition of fluid at constant volume. So volume is constant. So what is the relationship? So what happened kapag ka tumaas si pressure, tataas din si temperature or vice versa. Ano? So they are directly proportional, ano, si P1 and T1. So, the initial pressure is the P1, the final pressure is P2 in kilopascal or pwedeng PSI, and then our temperatures, initial is T1 and the final is T2. Okay? So, to find the work or the non-flow work for an isometric process, we will follow this equation. The non-flow work is equal to the integral of the napaliit lang yung aking lagay but then in some books ang pressure ay lowercase pero parehas lang ito. Medyo wag lang ma-confuse pag ganito yung itsura or which means density na ito So itong isa ay density pero itong dalawa parehas itong pressure. So we are going to utilize the integral of pressure times the differential volume from 1 to 2. So, kanina dun sa diagram, sabi natin that the dW is 0 or the change in work is equal to 0, which means that the non-flow work or PdV from state 1 to 2 is equal to 0. So, automatically, kapag kahinanap sa inyo or tinanong, determine the non-flow work of this process and then nakita ninyo hindi nagbago or constant ang volume, automatically the non-flow work is equal to 0. How about the change of internal energy? So last discussions natin during the midterms and prelims, I have presented this, the change in internal energy, mass, times the specific heat under constant volume. So we have CV. Kung depende kung ano ang tinatanong na fluid, pwedeng tama, it can be steam or it can be air. So depende kung anong constant niya or CV. And then the heat transferred, if you would notice, is just equal to the change in internal energy. Okay, parehas lang sila So naging iba lang yung symbol natin. We have delta U and for the heat transferred that is equal to Q. So maalin? So kung halimbawa ang isa diyan is unknown but then yung isa is already given or determined, i-equate lang natin, masosolve na natin. Okay? Let's have the change in enthalpy. So we have delta H. Ano lang ang pinagkaiba niya dun sa ating change in internal energy and heat transferred. So nabago lang yung ating specific heat. So instead of CV, CP, naman ang hinahanap natin. Ang constant na gagamitin natin. Okay. The change of entropy or delta S. Okay. So we have mass times the specific heat at constant volume times the natural logarithm of the quotient of T2 and T1. Okay? And how about the reversible steady flow constant volume? So kung kanina yung work natin, the non-flow work is just equal to 0, but then take note of this steady flow na tayo for a reversible constant volume process. So since we have the amount of Q which is equal to, okay, so galing siya dito actually sa formula natin na ito from this equation that the change in internal energy plus the change in kinetic energy plus the change in the steady flow work or flow work plus the steady flow work or the steady state system plus the change in potential energy. Okay? Since dito sa una, ito daw si change in kinetic energy at si change in potential energy are equal to zero. So, nag-come up tayo kay delta U, delta WF, and WS. Okay? So, we can solve now by deriving this equation. So, nakuha natin, na-determine natin ito, si steady flow work or work under steady state system. Okay, we have oh my, mali ata ang kopya ko ang aking type. We have this delta work or the change in work which is equal to, okay, we have the volume or the constant volume multiplied by the sum of P1 and P2. Okay, assuming that the delta K or the change in kinetic energy and potential energy are equal to zero. Okay, for letter B, okay, assuming, okay, let's say may value si potential energy or ang zero lang natin is just the kinetic energy. So to find the steady state work, so ito lang din siya, which are also equal. So parehas lang siya. V times P1 minus P2. Question, ma'am, bakit V lang? Anong gagamitin natin? Is it V1 or V2? Di ba constant volume? So V lang. V lang, iisa. And then for an irreversible, non-flow constant volume process, so we will have this equation, Q is equal to the delta U plus the non-flow work. Okay, so kapag irreversible, sabi natin kanina, kapag reversible, I mean, the non-flow work is equal to zero. So yung kanina kong diniscuss, for irreversible, ganun din, the non-flow work is equal to zero. Okay, kaya yung value ng ating non-flow work for reversible and irreversible are both equal to zero. Kaya nga yung heat transferred natin and change in kinetic, change in internal energy are just equal kasi the non-flow work is equal to zero. Okay, let's have a problem. Let us analyze this first. Okay, a scuba tank contains 1.5 kilograms of air. The air in the tank is initially at 15 degrees Celsius. The tank is left near an engine exhaust line and the tank's pressure doubles. Determine A, B, C, and D. Okay, the final temperature, the change in internal energy, and the heat added. Okay, identify muna natin what are the given. Okay, let us identify first what are the given. So we have 1.5 kilograms of air. So we have the mass. Okay, the air in the tank is initially, okay, it is initially at, so T1. So we have 15 degrees Celsius. Anong sabi ko last time with regards to analysis para mabigyan tayo ng more accurate answer pagdating natin sa analysis, we are going to use what unit of temperature? Okay, anong gagamitin natin unit?
Kelvin.
Kaya add ko sa 15 para siya ay maging degree Kelvin or
So, 73.15.
tayo ng 273. Okay, so therefore, ang gagamitin nating temperature ay 288 Kelvin. Ano pa ang ating given? The tank is left near an engine exhaust line and the tank's pressure doubles, na doble. So ibig sabihin, kung may given tayo halimbawa na P1, although walang given. So anong sabi daw? After a moment, what happened to the pressure? The pressure doubles. Kung meron tayong P1 nung una, na doble daw. So 2 times P1. Okay? 2 times P1. So, let us solve the final temperature. Okay, hanapin daw natin si final temperature or T2. Okay, what is the relationship ng ating formula kanina? So we have P2 over P1 is equal to T2 over P1. Okay? So what is the relationship between P2 and P1? Sabi kanina na doble. Ano? So yung P2 natin, i-express natin in terms of P1 since wala tayo namang given na pressure para makapag-cancel out tayo. Ano? So we have 2P1 over P1. Okay? Ang hinahanap natin is the final temperature and then our T1 is 288 Kelvin. Okay? Since wala tayong given na pressure, pero makakancel natin sila. No? So, therefore, anong value na nakuha natin? 2 is equal to T2 over 288 Kelvin. Okay, so, manipulate natin. Anong value ang makukuha natin dito? So, we have T2 is equal to 2 times 288. Pasolve nga ako. What is the value? What is the value? Times 2.
576 po.
Okay, 576 Kelvin. So this is the final temperature. Okay? Next, letter B. O, wag na kayo mag-screenshot. Ito naman ay isa-save ko yung aking solution bago ko isend sa inyo. Okay, let's have letter B. Ang hinahanap is the change in internal energy. Anong formula natin to find the internal energy? Delta U is equal to mass times the specific heat at constant volume, T2 minus T1. Okay? Okay, since air ito, ang gagamitin natin for air na CV based on the table, table 4 sa air natin. So we have the mass, 1.5 kilogram times the CV, 0.7186. Ito po ay para sa air. Kilojoule per kilogram Kelvin. Times the temperature. Ano yung T2 natin kanina? 576 minus 288 Kelvin. Okay, cancel tayo ng unit. So we have kilogram, kilogram, Kelvin, Kelvin. So what is our delta U? What is anong value ng ating delta U? Pa-check nga ako ha. 310
310.44.
44.
0.44 kilojoules.
Okay, nasakto yung 44 na yun o nag-round off kayo?
Nag-round up po.
Sige, okay lang hanggang 2 decimal places. Pag sobrang liit lang, let's say ang hinahanap natin is the CV or CP. So we all know naman na talagang siya ay less than 1 lagi. So pwede tayong gumamit up to 4 decimal places. Pag sobrang liit ng value na nakuha natin. Okay, so this is the change in internal energy. So let's have letter C.
Ma'am, yung
The heat added, or ano yung hinahanap dito na symbol? We have Q. So based dun sa ating formula or state relations presented earlier, so we have the internal energy plus the non-flow work. Tama. So sabi kanina, the non-flow work is equal to 0. So therefore, the amount of Q is just equal to the delta U, which is 310.44 kilojoules. So ito ay 0. Ayan. So it's just the same. So ganun lang mag-analyze. Kaya lang ito madaling i-determine for now kasi yung aking problem is just right after dun sa ating principle. So alam natin that it is under an isochoric or isometric process. So Pag sama-sama na siyang problem, you need to identify ano na ba ang ginagawa kong problem, anong process ba ito. So kailangan alamin niyo muna. Okay, let's have, gawin niyo na lang itong kasunod. Another problem. Masagutan na natin, isa naman ang hinahanap. Okay? The pressure in an automobile tire was checked at a service station and found to be 30 PSI, okay, G or gauge pressure, when the temperature was 65 degree Fahrenheit. Later, the same tire was checked again and the pressure gauge reads 35 PSI, okay, another gauge pressure. Assuming that the atmospheric pressure of 14.7 PSI did not change, what was the new temperature of the air in the tire? Okay? So, ang hinahanap natin is T2. Ang hinahanap natin is T2. Ano nga muna ako, anong ating given? Ayan, so ano yung mga given natin? Are we going to use that 65 degree Fahrenheit? Ano ba ang formula natin? Since ang hinahanap lang naman is T2. Ano yung formula natin? Same with this one. Okay, so we have P2 over P1 is equal to T2 over T1. Okay, by cross multiplication, since ang hinahanap ko is the T2. Okay, so we have T2 is equal to P1 times P2 divided by P1. So ito yung kailangan nating gamitin. Okay? So, what are we going to do? Okay, so ang gagamitin natin is the absolute pressure, same with the temperature. So ibig sabihin yung given natin na temperature, which is T1, anong value nun? 65 degree Fahrenheit. Paki-convert nga ako, gagawin nating Rankine. Or you can use Kelvin, but then yung ating mga units for pressure, mas okay kung gagamitan natin ang mga British thermal units. Okay, what is the unit to transfer into to Rankine? Anong value? 524.67 Rankine. Okay, so we have 524.67 Rankine. Ano yung gagamitin natin na pressure 2? Ito yung panghuli, So we have P2, we have P1, sorry. Our P1 is 30. But take note, it is a gauge pressure. After daw, it is 35 PSI G. So how are we going to convert them into absolute pressure? Ayan, binigay naman 14.7 PSI. You're just going to add 14.7 dun sa 30 and 35. So ano yung P2 natin? 35 plus 14.7 kasi sila yung mga gauge pressure. So anong value natin? 35 plus 14.7. We have 49.7. Tama PSI. And 30 plus 14.7, we have 44.7 PSI. So, cancel si units. So, our T2, ano ang ating value in Rankine? So, what do we expect? Anong ina-expect natin na temperature based dito sa ating formula? Si P1 30. Si P2 nag-35, yes? What will happen to T2?
Mag-i-increase po.
Mag-i-increase, okay. So, dapat ang makuha nating value should be greater than 524.67 or greater than 65 degree Fahrenheit. O, what is the value?
583.36. I-round up po ba? 36 po.
86?
36.
36. Sorry. Okay, 583.36 Franklin. Okay. Okay, question. Okay lang, ano? So, given naman lahat ng state relations, ng equations. So, let us proceed. Dalawa. Okay, let us have another process, to identify an isobaric process, okay? It is an internally reversible process of a substance during which the pressure remains constant. So, alin naman daw ang constant? Pressure remains constant. So, yung nauna natin is isochoric or isometric. Volume is constant. So, let us draw, considering that we have this system, okay? Yan, consider that we have this system. So, we have the heat applied or heat added. And then, ito yung magiging work natin. And then let us draw the PV diagram for a non-flow closed system of an isobaric process. Okay, the PV diagram. So, okay, let's say ito yung for some time, okay, for the first state, okay, ito yung ating B1, okay? So, meron siyang, let's say ito yung naging pressure natin. But then sabi natin, the pressure remains constant. So we are expecting a straight line here. So nagbago man si volume but the pressure is constant. So ayan. Pressure is constant. Okay? So from state 1 to state 2. Lagyan na lang natin ng arrow. Okay. And then sa TS diagram, ano naman ang itsura niya sa TS diagram? Okay, for the TS diagram, so let's say we have this T1 and we have this T2. Okay, the change in entropy or the entropy. Okay, so let's have this S1 and S2. Medyo kahawig lang din siya, kahawig lang din siya nung una. Okay. Ayan, so kahawig din siya nung una. So we have 2 and we have 1. Ayan. So lagyan natin ng arrow to determine na siya ay from state 1 to state 2. Okay, this is an isobaric process where pressure is constant. Okay, let us have the state relations or the different equations involved in isobaric process. Okay, the relationship between the volume and the temperature. Sabi natin kanina, the pressure is constant. So ito naman ang relationship niya. So tatandaan. So halos kamukha lang din nung kanina, instead lang of pressure, si volume naka-equate na kay temperature. So ganun din, directly proportional, V2, T2, V1, T1. So pag tumaas si V2, ibig sabihin si T2 is also increasing, okay? The non-flow work, so dun sa una nating process which is an isometric, the non-flow work is equal to 0. Okay? So kasi yung volume natin doon is constant, or hindi nagbago. Pagdating dito, ang constant natin is the pressure. So sabi natin, in integral calculus, kapag constant, pwede na nating ilabas. Ayan, so nilabas si P, and then the dV, which is the change in the amount of volume. So we have V2 minus V1. Okay, considering isang process path ito, pero kung let's say nagdalawa or naging tatlo yung states from 1 to 2 and then compute nyo naman yung from 2 to 3. Although lahat halos ng samples ko dalawang isang path lang, or dalawang states lang, 1 and 2. Okay, the change of internal energy. Is it just the same dun sa ating nauna? Okay, same lang. Under the constant volume, yung ating specific heat. And then the heat transferred, ayan, hindi na sila equal. Hindi pala talaga to equal sa delta H yun yung kanina. Okay? We have MCP. Okay? Instead of CV, we have CP. Okay? And the change of enthalpy, saan naman equal daw si change in enthalpy or delta H? So, equal naman siya kay Q. Equal naman siya kay Q. Same lang ng ating isometric, And then the change in entropy or of entropy, so we have MCP, the natural logarithm of T2 over T1, okay? What about the steady flow? The steady flow work or WS pagdating sa isobaric. So, saan ba daw ito galing? So, sabi natin kanina, galing ito lagi dito. Pinagsasama-sama natin yung mga change in potential energy, change in kinetic energy, change in enthalpy, and yung steady flow work. Okay? So, considering or assuming na yung ating potential energy, ayan, is equal to 0, so ang natira na lang natin, is just the delta K and the delta K and the delta P. Okay? So, kapag pinagsama-sama natin sila, ayan, so equating them, kasi itong lahat ay mag-equate, equal lang itong dalawa eh. Ito, nawala ito, tsaka ito. Kasi based dun sa ating formula, they are just equal. Okay, heat transfer Q, MCP, T2 minus T1, delta H, MCP, T2 minus T1. Okay, so ang natira na lang natin, huwag muna nating alisin yung delta P. So we have the steady workflow, which is equal to, lagay natin sa kabilang side, so we have negative delta P plus delta K or minus. This one is minus or i-enclose ko na lang sa parenthesis. Okay? So, saka natin alisin si change in potential energy. Kaya yung ating steady flow work is negative delta K. Okay?
Walang triple XL kahit saan, double XL lang. Meron happy, double
Wala na pong ibang brand. Ay, sige, happy na lang po. Okay po. Okay. Moving back, ayan. Wala na pala. Okay, so steady flow isobaric, so we have negative, the times the change is equal to negative delta K, or the change in kinetic energy. Okay, let's have this problem. Consider that 1 kilogram of air has a 21.7 kilojoule decrease of internal energy. Take note, yung term natin na 21.7 kilojoule decrease. While its temperature is reduced to 1/3 of the initial temperature during a reversible non-flow constant pressure process. Okay, determine the following. Okay, let us first identify the given. Okay, ano ba yung given natin? What is that 21.7 kilojoule? Ano yun? Internal energy. Okay, so we have delta U. But then take note, sabi ko yung ginuhitan ko, the term is decrease. 21.7 kilojoule decrease. Which means, na siya ay, anong ibig sabihin nun? Negative. Yes, negative. And then we have the mass of 1 kilogram. And then while its temperature is reduced to 1/3, okay, parang yung kanina, na nag-doubles. Kung meron tayong initial temperature, what happened? After dun sa ating second state or state 2, what happened to temperature? So, nag-reduce to 1/3. Naging 1/3 na lang nung una. 1/3 na lang ni T1 or T1 over 3. Okay? So, let us find first in letter A, initial and final temperature. Okay, ano yung formula natin to find? Saan natin pwedeng makuha using equation or state relation ni delta U or the change in internal energy. Anong formula natin doon? Delta U is equal to M CV T2 minus T1. Okay? So, since wala tayong T2 and T1, gamitin natin itong equation na ito muna before putting all or substituting all the given, yung mga numerical values. M, CV, yung T2 natin, i-express natin in terms of T1. So, we have T1 over 3 or 1/3 times T1 minus T1. So, therefore, we have the mass CV, 1/3 minus 1. So, we have negative 2/3 ng T1. Okay, saka natin i-substitute. Saka natin i-substitute yung ating mga given. I-derive ko lang to ha, i-simplify natin. Ilabas natin yung negative 2/3. M, CV, T1. Ayan. So, we have the delta U, or derive na natin ang diretsyo, by dividing both sides of equation by negative 2/3 MCV. Okay, so we have T1 is equal to delta U over negative 2/3 mass times the specific heat under constant volume. Okay, saka tayo mag-substitute. What is delta U? Negative 21.7 kilojoules over negative 2/3. Ang mass, 1 kilogram. Ano nga ang ginagamit natin sa air? 0.7186. CV ito ha, iba pa pag CP ang tinatanong. Kilojoules per kilogram Kelvin. Okay? Cancel si kilogram, cancel si kilojoule. Since si Kelvin ay nasa denominator ng denominator, so tataas siya or magiging numerator. So, ang value na natin dito is Kelvin. Okay, what is the value? It will become positive, negative divided by negative. What would be the value of our initial temperature?
32.55. Ay, hindi po pala.
Saan galing yun? Oh, how about the others? Basta parang si Mr. Albareco lang ang nagsosolve. Anong value natin? Pwede din namang
45.30 po.
45.
0.30.
5.30 Kelvin.
Ito? Ayan. 30, tama ba? 30.
Opo.
Ito yung ating temperature. Okay, kunin na rin natin si final temperature which is equal to 1/3 ni T1. Okay, so we have T2 is equal to 1/3 ni T1. So, ang T1 natin ay 45.3 Kelvin over 3. So, what is T2?
15.1.
15.1 Kelvin. So, ito yung ating letter A. Okay, the initial and final temperatures for an isobaric process. Okay, let's have letter B, the heat transferred, or the amount of Q. Okay, so ano yung ating formula for this? Okay, so letter B is Q ang hinahanap, or the heat transfer. So, diretso ko na, so we have mass, specific heat ni air under constant pressure, T2 minus T1. Okay, so ang mass natin is 1 kilogram. Ang CP natin ay iba sa CV, so we have 1.0062. This is for air. Kilojoules per kilogram Kelvin times T2 minus T1, we have 15.1 minus 45.3 in Kelvin. Okay? Cancel natin si Kelvin, kilogram. So, Q is in kilojoules. What is the value? So, we are expecting a negative Q or negative heat transfer. So, which means that the system lost energy, or nag-gives off ng heat. Anong value ng Q?
30.39. Negative po.
Negative 30.39 kilojoules. Okay, letter C. Let's have the non-flow work. Okay. Dito pala nalagyan ng subscript, or W sub N. So, anong formula natin doon? Anong formula natin for the non-flow work? Non-flow work. Anong formula natin doon? For the non-flow
Integral of PdB is equal to equal
isobaric tayo, constancy pressure. Although, okay, this is PdB P times B2 minus B1. Kaya lang, if you would notice, wala namang nabanggit dito na volume. Wala nabanggit na volume. But then, tama kayo, ito ang gagamitin natin formula, integral from 1 to 2, dPdV. So, in isobaric, so constancy P, so we have B2 minus B1. However, wala tayong given na volume. So, pwede natin siyang using mass and then yung ideal gas constant of air, which is R, times T2 minus T1. Or, it can also be equated, kasi nandito na tayo nakapag-solve na tayo ng iba, So, it is just equal to the amount of Q minus the change in internal energy. Okay? So, therefore, the non-flow work, ano yung nakuha natin? Negative 30.39 minus negative 21.7. So, the non-flow work is equal to negative 30.39 plus 21.7. O, negative pa rin ang value. Anong value natin?
negative 8.69.
Negative 8.69 kilojoules. Okay, take note of this state relations, kasi hindi palaging pwedeng instant na yun agad ang gamitin. So, based on the analysis pa din. Okay, let's have letter D. The change in entropy or the change of entropy. So, wala naman tayong ibang formula doon kundi M, Cp, the natural logarithm of T2 over T1. Lahat ba ay given? Pwede man nating masolve. We have temperatures. Na-solve na natin kanina, T1 and T2. Okay, we can proceed. We have 1 kilogram of air. Anong kanyang Cp? 1.0062 kilojoules per kilogram Kelvin times the natural logarithm of yung T2 kung nakuha T2 natin kanina. Mas mababa, 15.1 over 45.3. Okay, what is the change in entropy? Cancel si kilogram. Ayan. Cancel si kilogram. So our unit will become kilojoules per Kelvin. Hindi tayo nag-cancel ng Kelvin dito ha. Cancel na din sila sa ln T2 over T1, yung Kelvin over Kelvin. Ito ang unit natin, kilojoules per Kelvin. O, naka-natural logarithm yon. What is the value?
Negative 0.11.
Kaya? Negative? 1.
Negative point 1.11.
Negative 1.11 kilojoules per kilogram. Are you sure? Negative ang delta S. Kasi sa entropy natin, sa TS diagram natin, mas malaki talaga si S2 eh. S2 minus S1. Are you sure this is positive? Ln over 45.3. Oo nga, ano. Sige, okay lang. Negative 1.11 kilojoules per kilogram. Okay. So much for an isobaric process, or constant pressure process. Okay? Solve pa ba natin ito? Another problem. Okay, assume 0.9 kilogram of hydrogen simultaneously rejects heat and receives paddle work input in a non-flow change of state at constant pressure. Ayun, binanggit naman yung term eh. So you can easily identify, although hindi nakalagay na siya, ay isobaric process. From an initial temperature of 21 degrees Celsius to a final temperature of 32.2. If the heat rejected is thrice the paddle work, determine the following. Okay, let us first identify the given. Okay, ang given natin ay the 0.9 kilogram. Okay, the mass. We have temperature, we have initial and final. But then sabi ko, gagamitin natin ay absolute, 21. Ako lang ay typo error ha. This is supposed to be 121. Okay, so add tayo ng 273, and the other one is 32.2. So what are the absolute temperatures? Ano na? Okay, and the other one is 300.
305.2.
Ayan. Ano pa? Ano pang given natin? If the heat rejected, ano tinutukoy na heat rejected? Yung symbol yan. Anong tinutukoy na heat? What is that? Anong symbol yon?
Q.
Q. Heat rejected daw is thrice the paddle work. Okay. Thrice. Okay. Let's have a subscript. Thrice the paddle work. Okay. Identify the given. Okay. So, from the hydrogen table, since gagamit tayo ng CP and CV, okay? So, ito yung gagamitin natin for hydrogen. Okay, the value of CP, 14 kilojoules per kilogram Kelvin. Then yung CV is 10.2 kilojoules per kilogram Kelvin. Okay, ang letter A, ang hinahanap ay delta U. Okay, letter A, delta U, or the change in internal energy. Ang formula natin is the mass CV T2 minus T1. Lahat ba ay given? May mass, May CV, may T2, may T1. Okay, so ibig sabihin we can solve. Okay, substituting the given. Okay, pasolve ako ha. 0.9 kilograms ang CV, 10.2043 kilojoules per kilogram Kelvin. Ang T2, 305.2 minus 394 Kelvin. Okay? Cancel si Kelvin. Cancel ang kilogram. Okay, what is the amount of the change in internal energy? So based din sa ating T2 and T1, in this process, pababa so we are expecting a negative change in internal energy. Kilojoules. So ito yung ating change in internal energy. Okay, what about the delta H for the change of enthalpy? Yan, the delta H is equal to, ang pinagkaiba lang niya dito is TP ang gagamitin natin. Yan. So, 0.9 kilogram. Ang CP naman natin is 14.338 times T2 minus 394. Okay? What is delta H? Again, negative din. Ano ang change in enthalpy?
Negative 1,145.56.
Negative 145.56 kilojoules. Okay, we have the change in enthalpy. The change of enthalpy for the system. Okay, and the delta S. Letter A pa lang pala ang sinasolve natin. A lang din pala ito. Okay, the delta S for the change of entropy. A pa din. Delta S, ang formula natin is M times CP, the natural logarithm of T2 over T1. We have 0.9. Ang CP natin ay 14 times the natural logarithm of what is T2? So, yung mas maliit na value over 394. So, ang unit natin ng entropy is kilojoule per Kelvin. What is the value?
Negative 3.29 po.
Negative 3.
0.20.
29. Sorry.
Opo.
3.29. Yan. So, let us proceed to letter B. Tanong ay Q for the heat transfer. Mahaba-habang ano ito Okay, we have the delta Q. Delta Q only. Letter B. Ano yung ating pinakita kanina? Ayan. For the heat transfer, ang sabi natin ay if the heat rejected, yung Q is equal to 3 times the paddle work. Or W sub P. So, i-multiply lang natin or i-multiply lang natin by 3. However, given ba yung ating WP or the paddle work? Hindi determine muna. So our WP, so the paddle work means the totality or the summation of all the heat energy, coming, lahat ng work, So we have delta U, we have Q, we have work of the system. Alin pa dyan ang given na natin? So, gamitin natin yung ating nakuha kanina na base sa problem that the heat rejected is thrice the paddle work. Ano? So, substitute tayo kay Q ng 3 WP. Okay. And how are we going to simplify? Simplify natin. Let us simplify this. Ano natin isi-simplify? Si paddle work.
Transpose.
Okay? We are going to transpose. Ano? How are we going to transpose? Paano natin ita-transpose ito?
Yung 3WP po ba tsaka yung W magkaiba?
Yun na yung ating paddle work. O, pagsasamahin natin, ano, WP, saka yung 3WP. Okay, pwedeng lipat natin sa kabila since siya naman ang hinahanap natin. Ano. So, we have WP minus 3P. We have negative 2 WP. Delta U plus W. Since ang ating hanap is the WP, so we have plus W divided by 2. Huwag natin kalimutan yung negative. Ayan. Negative. Meron na tayong na-solve na delta U. Ano? Kaya lang wala tayong work. Ano? Wala tayong work. So, kunin natin si work. Ano, paano i-determine ang work in an isobaric process? So, constant ang pressure, ano, from state 1 to state 2, we have PdV. Okay? Or we can remove, ano, i-move outside natin yung P, which is constant. So, we have V2 minus V1. Again, meron ba tayong involved dito na volume? May binanggit ba na volume? So, wala, ano. So, we can associate, okay, based dun sa ating mga state relations, which has been discussed dun sa mga past sessions natin, MR T2 minus T1. Okay, so ito yung work natin. Okay, so pwede sigurong kunin na lang muna natin itong amount ni work para i-substitute natin dito, or kung gusto nyo, i-derive pa natin, ano, iisa-isahin pa natin. But then, wala naman tayong given. Ano, wala tayong given na amount ni the value of R, ano, or the universal gas constant. Or the gas constant for hydrogen. Okay, let's say, halimbawa, hindi natin alam yung mismong table of values. Halimbawa, limot natin. Ano, derive na lang natin. Ano, gamitin natin dito sa ating equation. Ano, where kanina ang ginamit natin kay delta U ay ito. MCV T2 minus T1. Okay? So, ito, ilalagay na natin dito. Kasya pa ba? Hindi na. Teka lang. Dodoblehin ko lang yung aking ano ha. So, we have WP is equal to negative. Ano yung delta U natin kaninang ginamit? MCV. Ano? So, we have MCV. Or pwede namang baligtarin. So, ito munang MR. Kahit alin ang mauna, okay lang. Plus naman eh. T2 minus T1 plus, anong ginamit ko kanina sa delta U? M V T2 minus T1 over 2. Ayan. So, derive natin. Anong constant, common sa kanila? Dun sa numerator, common yung T2 minus T1. Ano? So, ilabas ko na rin yung 1/2. Ano? Lagay ko na lang kay 2. Times, anong common? T2 minus T1. Okay? This MR, T2 minus T1 divided by T2 minus T1 is R na lang. Tama? Plus, this MCV, T2 minus T1, sorry, nilabas ko na pala si M. CV, T2 minus T1 divided by T2 minus T1. So, ang natira na lang ay CV. Ayan. So, ito yung gagamitin nating equation. Wait lang ha, magdagdag lang ako ng slide. Ay, sorry. Mali pala ang ginawa ko. Am I going to duplicate? Sige, wag nang duplicate. Okay lang ito. Okay. So, balikan ko. So, dictate nyo nga sa akin. Okay? So, we have WP is equal to, anong nakalagay doon? Negative.
M over 2.
M over 2.
M over 2.
Dito, ano?
T2 minus T1.
R plus CB.
Okay, R plus C2. Ayan. So, galing dito, ano nang kasunod nating gagawin? So, we can have the value of this work, which is equal to, saan equal itong ating okay. Ano yung relationship natin between our CP and CV? Ano relationship nito? Natatandaan pa?
Hindi po.
Ayan, ano, so the relationship of this gas constant. So, na-discuss ko ito during yung ideal gases before ako mag-solve ng compressible substance. Ano, R is equal to Cp minus Cv. Okay, so, kung diderive ko to, so R plus Cp, R plus Cv, ayan. Ayan, so R plus Cv is equal to Cp. Tama, ano? So, ayun pala ay equal to what? Cp. Ano, ito naman ay just in case lang na hindi mo memoryado. Ano yung table? Kasi pagdating sa board exam, madalas or minsan, typo error, hindi nila nalalagay yung table of values ng constants. Kasi they are also assuming din, kaya sadyang hindi nilalagay dun sa ibang exams, is that you should memorize that. Ano, so dapat tandaan ninyo. But then, kung nalimutan mo, derive mo na lang ng pagganito. Ano, so therefore, pwede daw natin pala siyang ganituhin. Ano, so we have M over 2 times this T2 minus T1. So this R plus Cv is just equal to Cp. So ano nang kamukha nito? Lagay natin nga. So we have negative M Cp T2 minus T1 over 2. O anong kamukha niyan doon sa ating formulas na ginamit? O, balikan natin.
Heat transfer.
Change in what? MCP T2 minus T1 is equal to the delta ano? The delta equal lang to delta H. Ano? Ayan, nakuha na ba natin delta H? Nakuha na natin yan. Yun, no? The letter A. So, equal lang pala siya dun to delta H over 2. Hindi mo na kailangang mag-solve ng bago. So, ano yung given nakuha natin kanina na delta H? Negative 1145.56. Negative 1145.56 kilojoules over 2. So, ito yung paddle work natin. What is the value? Negative. So, hindi pa tayo tapos kasi hindi naman paddle work ang hinihingi. Tama? Anong hinihingi? In letter ano ba tayo?
Yung Q po.
B. O, Q pa lang ang hinahanap. Balikan natin yung ating ginawang equation na siya ay thrice ni paddle work or 3WP. O, i-multiply natin siya doon. 3 times negative. So, pakimultiply nito. Kilojoules. So, the amount of Q, this is letter B. Ayan. In kilojoules, negative, anong value na?
1718.30.
Anong kasunod?
8.34.
0.34.
0.34 kilojoules. So what is the indication of this negative sign pagdating kay heat or Q? Anong sabi kanina? If the heat rejected, okay, meaning to say, yung negative sign natin, it indicates that the heat is rejected based on the analysis, based sa problem, which means that the system lost heat or nag-gives off ng heat. What about yung paddle work? Bakit naman siya negative? 'Di ba dun sa ating sign convention, may ibig sabihin yung negative and positive. O pagdating kay work, bakit naman siya negative? Anong indication ito kay paddle work? Ito ibig sabihin, the heat is rejected, kaya siya negative. O what about kay paddle work? Work pa din naman yun, Negative siya, which means, ano ibig sabihin kapag negative? Work is
Rejected.
Work is applied. Work is being applied to the system. Ayan, to the system. So, tama lang, we are expecting na magkaroon ng negative na work. Okay? Meron pa tayong hindi nasosolve, Isa pa? Okay, dagdag uli ako ng slide. Okay, let's have letter C. Anong question sa letter C? Letter C ay WNet or the network. Okay, the network of the system. Okay, the network of the system. So, let us identify or solve first for the non-flow work of the system. So, pag sinabing network, lahat ng work being done or being applied into the system, including the paddle work, including the non-flow work, kung yun man ay steady flow, So, solve daw muna natin. Solving for the non-flow work. Okay, solve muna natin si non-flow work of the system. So, the non-flow work is equal to MR T2 minus T1. Okay? So, we have the 0.9 kilogram. We have the R of the hydrogen or the gas constant for the hydrogen. 4.12. 552. Kasi ma'am, pinahirapan kami kanina, may amount naman pala si R. May value naman siya talaga, Kaya lang I just wanna show you the relationship between this R, CV, and CP. So dito pa lang, pwede na ninyong directly isolve, kasi may CV naman at R. Si hydrogen or any gas, or any material, meron naman siyang corresponding CV, CP, and R. Kaya lang in-identify natin, pinasimple natin. Okay, ano yung value ng T2? Anong value ng T2? Saan ang T2 na ginamit natin sa given? 305 and 394. Ay, sorry. 305.2 and 394. Okay, what is the value or the work, the non-flow work of the system? So again, since magni-negative tayo sa temperature, we are expecting na magkaroon tayo ng negative na non-flow work, which means work is being applied to the system. Ano? Anong value nito?
Negative 29. 329 po.
3?
0.71.
3.71?
300,
Negative
negative
329.
329.71.
Kilojoules. Okay, the non-flow work. Hindi pa tayo tapos. Ano pa ang mga kailangan natin? May paddle work na tayo, nakuha natin. So to find the network of the system, so summation siya, no? Summation ng lahat ng work done or applied sa system. So paddle work, tsaka itong non-flow work, i-add lang natin. Ano? So the paddle work, anong value natin kanina? Negative 572.78 plus negative 329.71 kilojoules. So the network is equal to negative
902.49.
902 point
49.
ano?
49 po. 49.
49 kilojoules. Yan, no? Again, negative. Ano? So, as is naman, ano, as expected, nakakuha tayo ng negative na net work of the system. Madami-dami pa ito eh. Yan. Okay, we will move on to isothermal and isentropic by next meeting. Ano? So, by next week. So, teka lang, papakita muna ako. May question ba sa ating... Nasaan na? Do you have questions?
Meron po. Yung sa, ano po, ng flow work, pwede siyang ano na lang, Q minus change in internal energy instead na MR times T2 minus T1.
Sa, depende maximize natin. Depende sa given kasi hindi natin pwedeng ipilit yung isa kung hindi naman given yung mga volume, halimbawa.
Pero pag even po, pwede siya.
Equal lang sila, ano? Okay? May tanong pa? May klase ba kayong kasunod? O 10:30 na din naman pala. Anong oras pa tayo nag-start? 9 o'clock? Saktong 9:30 na ata.
Opo.
Okay. So, we will proceed by next meeting. Mag-send ako ng ilang activities with regards to dadalawa pa naman tayo eh. Dalawang, tama ba? Dadalawa pa ang na-solve natin. Dadalawa pa ano? Isochoric and isobaric pa lang ano? Okay, so babalikan ninyo although if you would notice tapos na yung prelim, tapos na yung mid